Yeah, I'm going to be making an automatic blind using a light sensor, and this is an Arduino Micro Pro, it says there, but you could use a normal Nano or even a Pi. Just testing it out with Blink. These headers on first. All the headers are soldered in. It's best to put it in a board when you do it so they're straight. I think you obviously know that, don't you? I chose a Micro because it's a lot smaller than what I could have used. I could have used a Nano, an Arduino Nano, or a Pico, Raspberry Pi Pico. But I mean, there's no point, is there? Because I'm only going to be using one analog leg and a couple of digital pins. So there's no point having all, massive computer power just to do that. This is a Nano with a RTC real-time clock attached. It's quite big really. It takes up quite a lot of room, and we're trying to save a bit of room, and that's getting rid of that's going to save a bit of room. So you want one of these. I've forgotten what the number is now. Find out later on. One of these what they call these things for the stepper motor drivers. You need a driver, and then you need a 10 kilo ohm resistor and an LDR light dependent resistor. That's all you really need. Yeah, so this is my last attempt. I'm trying to get away from it to make it a bit tidier, you know. This is a bit rough, isn't it? But you can see it's hanging on a bit of masking tape there. Very professional. So this is how the light sensor is going to be connected. The resistor, the 10k resistor, is going to be connected from the analog pin 0 to earth, and the LDR is going to be connected from the analog pin 0 to positive. There you can see that, look there. That pin there, that one there, is where the power is going to come in. I've got to find out if I can put 12 volts into it yet. It's the first time I used one of these micro boards, so I don't know. Just going to test the LDR. I've got the Blink program running at the minute on pin 9. So just loaded an example program. So the LDR is working alright. So it's an A4988 driver. There's plenty of info on how to wire them up on the internet, but that's the power coming in. It can be 8 to 35 volts coming in, and I put that voltage going over to this side of the micro. So that's going to be powering the whole thing. Next, I need to get a capacitor across the live and the negative blinds. 47 ohm capacitor fitted across the positive and negative. So we've got the earth connected, so this is the main power coming in, and then we've got to put the positive there, connected to the positive rail, and an earth there connected to the, I think I've got it right there. Oh no, I've got it wrong. Next one down. Sorry about that. Yeah, so them two are connected, look. The bottom one, the bottom pin to earth. Next one up to the positive rail. So that must be getting 5 volts to there. So you've got power coming in, power going to there, and then the 5 volts is being produced and coming back down to the rail down there. This is a video on YouTube from How to Mechatronics. Well done mate, you sorted me out. So now I put a jumper cable from there to the next one up. And then we go from here. Oh, let me hold that. up to number 4. I want to look which one that is. Yeah, I'm just using the pins just in case there's a problem. Direction, this is a direction one, that looks a bit, oh dear. And put that to number pin 3. You don't have to use a torch, but if you're blind like me, it helps. So that's pin 3, yeah, okay. So I'll be using a NEMA 17 stepper motor. I think these wires are all soldered, so they might push in, might be lucky. This looks like it's been outside, doesn't it? All the plates come off, but yeah, nice. Look at my telescope. What I've done, it's blue next to the capacitor, then red, then green, then black. Do you get that? Yeah, so I've got all the wires in. I've soldered them on. Look, I've tried pushing the bare wires in and they won't go in the circuit board, obviously. So I've got it from at the top going down, blue, red, green, black. Hopefully that helps out. Well, hopefully that little program there should run the stepper motor. So I'm just going to download it into the Arduino and then take it into the kitchen on a 12 volt supply and then try turning it on. I'm just going to check, make sure that the micro can accept 12 volts before I blow it up. So I'm wired up. All working up. It's running at full speed at the minute. If you want to slow it down, you can connect them three there to 5 volts. And then this one is to enable the motor to be on, powered. I think 0 volts is the motor on, and if you put 5 volts on this pin, then the motor will turn off. So you want the motor to turn off when it's not being used, so it doesn't overheat really. So I'll transfer it onto this board. Not bad then. I put a connection there so you can put the light sensor on afterwards, because I don't really know how long the wire's going to be. And so just linked all up underneath. So put these quite close together. So 2 and 3 is direction and step, and then enable is number 9 pin at the back. Join them so you can just join them straight on. It's easy. Saves mucking about, doesn't it? Straight across, just bend the pins over, and hopefully that's it. So I'm going to mount it in this. Get the motor mounted in there next. So I'm probably going to have to smash that bit out of the way. I mean, you can smash that bit off anyway because the wires go through there. So smashed a bit of it out. I think I'll get rid of this central part as well. Here's the circuit diagram before I go any further. I don't actually have to smash that socket up so much, because you don't have to go down all the way, look. It needs to go about, get it levelled up with the rest of the blind. The motor actually wants to sit just above the socket, which is a bit of a pain. I thought I got the longest socket I could, highest socket. So there we go, it makes it easier in a way. And mark out neatly where you want the hole to go, which is what I've done. Holes drilled, exciting stuff. I'll put the motor in now. It's a bit higher than what I wanted it really, but I'll have to do. Let's glue it in now. Some epoxy resin, I think. Next, I need a socket, an adapter. Need to also make the LDR extension, so I can plug in. I've got some plugs, some female plugs outside. The glue's dried on the motor. I poured some epoxy resin in there, and I used some silicone just to hold it in place. And I drilled a hole in there. I forgot to do that with a socket. Oh, it fits, look. Beautiful. Nice socket, look. So the next job is to attach the wires to the circuit board off the stepper motor. NEMA 17, by the way, I forgot to mention that. Got the motor wires, 4 motor wires connected up. Soldered on the back there. Got a socket fitted. I can only find a 9-volt power supply. I wanted 12. Looks good though, doesn't it? Then there's the positive and negative connected up, inputs voltage, and then that's just the light sensor there. So it is really ready to go. I'm just going to, oh, can you see that, look? That's what you be careful of. If the curtains roll down quickly, they'll feed back power into the system. Hey, at least I know it's working. And it'll blow your driver board up. So you've got to be careful not to let the blinds drop. Yeah. I'm just going to load this program into the to the board and see if the stepper motor works. So let's plug her in and see what happens. There's the socket down there, look. Ooh. Champion. It's quieter if I lift it off the what's going on there then? Oh dear, someone's drawn a picture of a penis. Idiots. I've had to do this freehand because the cat's in the way of the tripod, but the light sensor's there, and when I put my finger over it, it'll close. But the trouble is, if I do it again, it will close again. Put a torch on it, opens. So I need to put a variable in to say the blind is closed or open, so it won't do it twice. So I've got it working a bit better. Now it thinks the blinds are closed. Put lights on. Thinks blinds are open. It's not going to open them anymore. Oh look. Oh, it's too light. It will close. But it won't close again until you put light on. That's a bit sorted out then. Good night, I'll see you in the morning. The shaft size on this stepper motor is 4mm, but you can get 17 NEMA 17s with 5mm shaft with chamfer down the sides, and when you've got them it's a lot easier because you can just make a tube and just crush one end down and glue it into your blind hub, how do you call it, so you can just crush that end down there and it'll just go on and it sticks on. But obviously no chamfer on it. I'm going to have to make an adapter, and I could grind a chamfer on, but I ain't got any 4mm internal pipe anyway, so I've got to machine something. So you can see you've got that end of the blind, and then at this end you've got that bit there, so I've got to make this fit on there. I might saw that bit off actually. Yeah, anyway, we'll see what happens. So I used a bit of brass pipe fitting I found. The first bit was already drilled and that's quite loose, but the next bit is what I've done and it's quite tight, so I'm just not going to try and put it on yet, just in case I can't get it off. So the next job is to make this fit in there, glue it in. Oh, it's not too bad really. Oh, that's not bad. Oh my lord. Oh, look at that. This is a... Oh, that is it. I'm just going to glue that in. This is off a dinghy, rubber dinghy compressed air pump. Stuck a bit of glue on just to stick it in place, and then I'm going to pour more epoxy resin down the hole. I got these cogs a while back, and it would be a good idea to use that really, but it's a bit late now. But yeah, that would be sort of... Ooh, that would be a bit better. But we're stuck with what we got. Well, I've got the drive on. See the light coming on there again still, can't you? So we're all ready to go. There's the light sensor. I've got to push that through the bottom and out the window. Fitting the curtain, the blind, just drilled 2 holes. I was going into lintel last time and it wasn't working, so I glued it to the wall and I ripped all the plaster off. As you can see, there and there, all plaster come off, nice. First bracket on, and I've repainted a bit. Main bit on. Right then. Well, that's it, powered up. I've just got to set it all up now. As you can see, look, it's actually going the wrong way around. That's supposed to be closing. And it's only going 1 turn. I've got to work out how many turns it's got to do and just tweak it. So what I've done, I've glued under here, when it's all the way down to the bottom, I've glued under there because the weight pulls the motor down. When it gets too far down, it pulls it down. So it's either that or release all the blind and then cut it off to the right length, which I was going to do. I might do that second if this don't work. But it just means it won't just keep falling all the way down and drag all the way onto the floor. Okay, so here's the program that we're going to test it with, and just setting up as normal. When this goes to open, look, when it goes to open, it does a loop, and 3,200 is 1 revolution. I'll just put it to 32,000 loops, so that's 10 cycles of the blind, just to test it out. So in the morning when the glue's dried, I'm going to drop the blind to the bottom. I'm going to run the program. The program automatically thinks it's at the bottom when it starts up, so it will open up 10 loops, 10 cycles, and then drop down 10 cycles. We'll just see if it's enough. It'll make sense when you see it anyway. Alright, so next day and the glue should hopefully be dried. We'll just try it out, see if it is. Well, there you go. It stops. For a sort of semi-final program, I'm going to make it better in the future. Like I'm going to make a rolling average for the blind sensors. So if you get a security light comes on, or someone's trying to torch in the window, or a car goes past with a high beam on or whatever, then your blind doesn't open willy-nilly. So you do that by adding the values together of the reader and doing a rolling average, and I'll put that in the program when I finish that in the comments. And then there I've counted 12.25 turns on the blind, and that works out at 3,200 times 12.25, and that's what it equals. So that's going up and down that many points. There's only there, look, you closing, sorry, you're opening, and there's your closing, simple as that. And there's where it's detecting the light. It just goes to close or it goes to open, depending on the light level it detects, and depending whether the blind's closed or open, so it don't keep opening and don't keep closing it all the time. So that's it then. I'll go and put it in the Arduino. Can you see the bottom part? You can't see the bottom part, can you? Sorry about that, people. Anyway, I'll put it in the comments. So here we are, final testing. We start it off in closed position because that's the default. Right, turn it on. Oh. Oh, what? Oh dear. That was 1, 2, 3 times. 4 times. I think I've made an error with the calculations. 5 times. 6. Can't use massive numbers on 4N loops, so I've just made 2 loops. Sort it out. Anyway, so. One, too many. So I've got to lower that number down by 1, but it looks like it's there, isn't it? I'll sort that out. Okay, so final test. Come on, baby. Oh, yeah, that's it then. Check it closes. I'll cool up the sensor. I'll have to get some weight for here. Get a bit of bamboo, because I don't know if it'll be heavy and too heavy. The actual plastic bit that comes with it, it's quite heavy. It normally goes through there, but oh, I can finally get some private in the kitchen. It should wait 2 seconds once it's closed, and then it'll open again. Yep. There you go. Everyone's a winner. Thanks for watching, everybody.